All right, everyone, we're going to go on to chapter 7, which is about estimating parameters and determining sample sizes. So the first section is actually going to only be about proportions. Remember, proportions are the same as like percentages or decimals. We're going to stick to pretty much decimals in this. And whatchamacallit, we're going to be using the variable p and p hat. Okay, and I'll go over these notations one more time a little bit later, but we did see these at the beginning of the course. So some key concepts, and you're going to see this definition twice just because they're that important. So some key concepts are the word point estimate. So like, for example, if I wanted to know what the percentage of the population has an Instagram account, for example, I'm obviously not going to ask everyone. Instead, what I'm going to do is I'm going to pick a sample and ask them. And I'm going to find the point estimate. Okay, so the point estimate is the proportion p hat. So that's like the percentage of people I ask that actually have an Instagram versus everyone else. So it's the best point estimate of the population proportion p. And so what this is like me estimating like, hey, approximately 74% of people own an Instagram. Versus like the entire probability of p would maybe like only like 40% in the world actually own or have an Instagram. The next word or vocab is confidence interval. So how confident are you that the answer you got is actually the answer that it is? And so we can use a sample proportion. So this is my group of people that I asked how many people have an Instagram proportion to construct a confidence interval estimate of the true value of population proportion. So we know actually how to construct a confidence interval. Okay, so a confidence interval is like a start and stop of how many people or what percentage of people have an Instagram account. The last one is the sample size, and you guys already know this. We've done this before. It's lowercase n. You should know how to find the sample size necessary to estimate a population proportion. Again, we're going to be using some algebra and an equation to help you solve that. So going into more of point estimate, it's actually going to be the same definition. It is a single value used to estimate a population. So used to estimate a population parameter. The sample proportion p hat is the best point estimate of the population proportion p. So remember, the hat is about sample and the population proportion is just p. Okay, so example 1, this is not really more of an example, there's really no question, it's just like interpreting data. So it says the chapter problem includes a reference to a Gallup poll, which 1,487 adults were surveyed and 43% of them said that they have a Facebook page. Based on that result, find the best point estimate of the population of all adults who have a Facebook page. Now, obviously, I don't know the exact percentage, but since the sample size is really big, we're going to assume that the number that we got is actually very close to the actual number. And we don't really know that, and that's why we do, that's why we're doing this chapter. Okay, so I'm going to say because, so again, there's really no like question to this. I'm just talking about what this means. So it says because the sample proportion is the best point estimate of the population proportion, we can conclude that the best point estimate is p equals, and remember we like it in decimals, instead of 43%, we're going to say 0.43. Now again, we don't know if that's true or not, but that's why we're going to do some testing and estimating, essentially. The next one we have is confidence intervals. So a confidence interval, and I actually don't like writing the word confidence interval or the words confidence interval. So we use, well, it's also called an interval estimate. And again, a lot of words. Instead, I like using CI, confidence interval, is a range or interval of values to find an estimate of the true value of a population parameter. A confidence interval sometimes is abbreviated as CI, so same thing as I wrote before. All right, so a confidence level, which we're gonna write as CL, okay, so CI versus CL is the probability, and the probability is gonna be 1 minus alpha. And this is the Greek letter for A, so this is called alpha. And that's actually going to be your formula, such as 0.95 or 95%, that the confidence interval actually contains the population parameter. So what this is I'm saying, how confident are you? You're saying, oh, I'm 95% confident that between this number and this number, the answer is lying in between there. Assuming that the estimation process repeats at a large number of times. The confidence level is also called the degree of confidence. And again, I don't really use this. I just use confidence level, or CL, or the confidence coefficient. And this is from your book. Again, coefficient. I usually just use this word, or CL. Okay, so here's an example. These are the most commonly used. Now, there's other ones out there, like I might change this to 98%, and you might need to check what that is, but we'll again go over this. So if you're 90% confident, you're 0.9, your value of your alpha is 0.10. And how did I get that? Well, what I did was I did 1 minus the confidence level. Okay, so for example, 90% is 0.9. Okay, so what I did was I did 1 minus 0.90 or 0.9, and I get 0.10, and that's what your alpha is. Okay, so if I give you your alpha, you can find this number, and if I give you this number, you can find your alpha. Essentially, that's what we're getting at. Okay, so like, for example, if I gave you your alpha as 0.05, you could figure out that this is 95, because together 0.95 and 5 add up to 1 or 100%. Okay, this sentence frame we use to interpret confidence intervals correctly. So I'm gonna have you, and it's starred, it's like bolded, it's underlined. You're gonna have to memorize this, or you're gonna be using this. And I told you guys we'll be using sentence frames. We're gonna be using this sentence frame a lot. So I'm gonna write memorize. And I'm also gonna write, this is for proportion. Okay, there's going to be one for mean and one for proportion. So there's actually only 2 sentence frames you need to know. This is one of them, and then you'll see the other one in 7.2. All right, so moving on to the next page, this is the next part is your critical values. So your critical values is the number on the borderline that separates the sample statistics that are significantly high and significantly low from those that are not significant. Okay, so that's a critical value. Think about it, critical values are important. They're critical, right? So the number, and it's going to be z of alpha over 2, is a critical value that is a z-score with the property that the border separates an area of alpha over 2, which is half of alpha, in the right tail of the standard normal distribution. I know that's confusing, so we're going to go ahead and we're going to draw a little picture, and I'm going to give you guys like a little bit of directions, and then we'll try an example. Okay, so we're going to be using a normal curve, and that's why we teach normal distribution a lot in here. So inside this is my, like, for example, 95% confidence level. So this is your confidence level. Okay, now if this is your confidence level, what's your alpha? Okay, essentially I'm doing this example right here. Yeah, let's keep going. Okay, so that's so how much percentage is left over? Well, I'm gonna write confidence level is a percentage. So 95%, it doesn't always have to be 95, but since 95 is this example. Okay, and then what we're gonna do is we're gonna find alpha, which is 1 minus the confidence level. And I'm gonna do the work down here because that's what the question is asking. But so if we're looking at 95% confidence level and we're looking for alpha over 2, what essentially we're doing is we're gonna first find alpha. Okay, so yeah, let's go ahead and find alpha. So we're gonna do 1 minus 0.95, which is 0.05. Okay. The next thing we're gonna do is we're gonna go ahead and we're gonna try to figure out, okay, so if that's 5%, okay, what is alpha over 2? So let's go ahead and write some steps over here. So the step 1 is you have to first figure out your confidence level, which is 95%. Okay, so step 2 is you have to find alpha, which is 1 minus 0.95, or whatever so if this was like 98, it would be 1 minus 0.98, kind of depending on what that is. So we get 0.05. Step 3 is to figure out what's left over. So what we're gonna do is what's left over divided by 2. So alpha over 2, so we're gonna do 0.05 divided by 2. And I'm just gonna take my calculator and divide it out, or if I know what half of 0.05 is, which is 0.025, I'm good to go. And so what that means is that in here is 0.025, and in here is 0.025. And if you think about it, that means that all 3 of these numbers should add up to 1 whole percentage, or 100%, or 1 whole, because it's an area under a curve. So density curves means it's 100%. And that's why we use this. So if you want to label this is alpha over 2, and this is alpha over 2. I know my alphas look like 2s. I'm not very good with Greek letters. Okay, and so the 4th thing we want to do is we want to figure out what is your z-score here and your z-score here. Now the beautiful thing is they're going to be the same z-score, except this one's going to be the negative answer and this is the positive answer. Okay, we actually want the positive answer, but I'm going to show you guys how the negative answer is actually a lot easier to find because, well, we're going to be using this. So if this is a z-score, how do I find a z-score if I know this is a normal distribution or standard normal distribution? Well, if you remember back in the day, from the last chapter, in standard normal distribution, your mean was 0 and your standard deviation was 1. Okay, so what that means is I'm trying to I know 0, I know 1, and I know the area under the curve because it's 0.025. And so essentially what we're doing is we're going to be using inverse norm. Okay, so from the last chapter, how we got there, if you remember using inverse norm, is what we did was we hit second, and then we went to vars, and then we went to number 3, I think, which was inverse norm. Okay, so we use inverse norm, and we're trying to figure out the percentage. We're trying to figure out like what your z-score is with that as your percentage. So the first thing you want to do is look at the area. And the area is 0.025. Your mean was 0, and your standard deviation was 1. And if you remember, I always made you guys label it. So area, mean, and sigma. Okay, so step 4, I'm going to write use inverse norm. Okay, so I'm going to go ahead and do that. So I'm going to go to second, vars. I'm going to go to number 3, and then my area under the curve is 0.025. My mean is 0, and my standard deviation is 1, and I'm using the left. It's always left. Again, if your calculator doesn't say left, it automatically means left. And you're going to get this. Now, how many decimal places do you want to round to? You want to round to 3, always. But if you look at it, this is negative 1.9599. So the 9 bumps that 9 to a 0. So we're going to say, in this case, your z is equal to 1.96. And you're like, but it's negative. Yes, but remember this number and this number are actually the same number. Okay, so this is just the negative of 1.96, and this is the positive 1.96. 1.96. Okay, so we're going to stick with the positive value of this. How would I actually get a positive value if you were doing a calculation? Well, instead of doing 0.025, if remember, the area is always the shaded region to the left. So if I were to actually find it, I would actually have to shade in all of this. So I would add 0.95 to 0.025. In my area. So I'd do 0.025 plus 0.95, and that'd actually get me my area. Okay, and I would get the positive 1.96. Again, because it's always the area shaded to the left. So it's the same number, except I like just doing this number and then changing it to a positive, and it just makes your life easier. So I said use inverse norm and label. And we actually found our answer. Find the critical value of 95% confidence. So z equals 1.96. Now, you're going to eventually memorize these, but these are the most common ones, and I actually wrote it out for you. So these are your confidence levels. Now, I think for your homework, I might have asked like 98%, so you might actually have to calculate it this way. But these are the ones that like you use a lot. So 95%, if you look, is 1.96. 99% is 2.575, and so on. So again, I'm going to have you guys memorize in this, because that way you don't actually have to keep doing the calculations. All right, so the next part is we're going to go ahead and go into the margin of error. Okay, so sometimes you're going to be wrong, and you're going to like, okay, well, how off are you? And that's called the margin of error. So like you're gonna say, oh, I'm 95% confident, but there's gonna be a little error. And that's essentially what this part is. So it says when data from an SRS, and if you remember, an SRS is a simple random sample. Who wants to actually write this out? No one, that's why we use SRS. Are used to estimate a population proportion. Remember, population proportion is P, the difference between the sample proportion, which is P hat, and the population proportion, P, is an error. So what we're essentially doing is we're trying to find the error of how off are you from your P hat and your P. Okay, the maximum likely amount that the error is the margin of error. So it's like the max of how off you are, and it's denoted by just in capital E. Okay, there is a probability of 1 minus alpha, such as 0.95, that the difference between P hat and P, or P and P hat, is E or less. The margin of error, E, is also called the maximum error. I don't use that, maximum error, but your book does. Okay, can be found by multiplying the critical value and the estimated standard deviation of the sample proportions. That's very confusing. So here is the formula that this essentially is getting at. Okay, so your formula is your margin of error is equal to, and this is how you calculate how off you are, is your z value of alpha over 2, which this is from the chart above, times, and they use a star, don't know why, but it's always been a star, which really means times. So I'm going to say multiply. And you're going to multiply it by the square root of P hat times Q hat over N. Okay, and hopefully you kind of remember what everything is. If not, that's okay, because it's right down here. Okay, so some notations. Again, what does E stand for? That stands for your margin of error. Okay, your z of alpha over 2 is called your critical value. I'm just kind of going through the list again. And if you go through this, what was P hat? That is your sample proportion. What's Q hat? Now remember, you get that by subtracting 1 minus P hat. Okay, it's the sample proportion that's not true. And then what was our lowercase n? That is our sample size. Okay. And then it asks you your requirements, and I realized I didn't leave enough space, so I'm gonna go on to the next page and I'm gonna rewrite the word requirements. Okay, so at the top I have the space for it, so we're gonna say requirements. Okay, so I'm not gonna go through every single one of them, but there's 6 requirements. Now you only have to check 2 of them, but there are 6 of them, and this is your bins, if you remember this, plus the 2 extra from the last chapter. So you remember it, bins is, the first one's binary, so is there a success versus failure? The second one is independent, so are they independent of each other? The third one is fixed number of trials. Your fourth one is the success remains the same. Remember the bins. Now, what did you learn last chapter? You learned 2 more. So number 5 was going to be NP is greater or equal to 5. And I'm going to grab a different colored pen because this one is dying. NP is greater or equal to 5, and NQ is greater or equal to 5. And then the 6th one is going to be, it says SRS, or simple random sample. Okay, so that's essentially it. Okay, so those are your requirements. Now, your confidence interval estimate of P. Okay, again, your book does it 2 ways. We're going to go through both of them. And so the first, or they're actually the same thing, but it's your P hat plus or minus your E. But that's not how you write it. You actually write your answer in an interval. So you remember, like when we did normal distribution, you had a start and a stop. That's essentially what you're doing. So this is going to be P hat minus your margin of error, and this is going to be your P hat plus your margin of error. Okay, so think about it. Lower, so this is the low, and this is the high or upper. Okay, and then you're going to write sentence. Okay, the round off for confidence interval for P, so I'm going to say 3 decimals, which is usually the majority of the time, or whole number if finding N. So if you're asked to find a confidence interval, you're going to round to 3 decimals, but if you're trying to find N, how many people, that's the number of trials. Remember, number of trials has to be a whole number. Okay, so here are the steps. The first one is you're checking requirements. The second step is to find z of alpha over 2. You can either use the chart or you can use inverse norm. The third is going to be calculate E. And then the fourth is going to be confidence interval and sentence. The fifth is going to say round, well, it's not really a step, but it's going to be round to 3 decimals. Sorry, guys. All right, so let's go ahead and do an example for me, please. So in chapter 5 problem, we noted that the Gallup poll of 1,487 adults showed that 43% of the respondents have Facebook pages. So this is the same example from example 1. Okay, the results are N equals 1,487 and P hat is equal to 0.43. Okay, so if P hat equals 0.43, how do I find Q hat? Well, that's just 1 minus 0.43. So if I use my calculator or just subtract them, I get 0.57. So first step says find the margin of error E that corresponds to the confidence level, or 95% confidence level. Okay, so since we're looking at 95% confidence level, we're looking at our z of alpha over 2, and I'm just looking at the chart, or what we just did is 1.96. Okay, so we're going to use the formula E. Again, remember E is going to be equal to z of alpha over 2 times the big square root of P hat times Q hat over N. Okay, so what is our z? Alpha over 2, that's 1.96. Times a big square root of P hat, which is 0.43. So I'm going to write this I'm going to multiply it out like this, times our Q hat, which was 0.57, all over our N. And if our N is 1,487. I'm going to use my calculator, and remember, what are we rounding to? We're rounding to 3 decimal places. So I'm going to go ahead and do 1.96 times the square root of parentheses 0.43, parentheses, times parentheses 0.57, close my parentheses, divided by 1,487. And look, if you look at my thing, the radical goes all the way through. So make sure you get that. And if you get this, we're going to round to, again, 3 decimal places. So we get 0.025. Okay, and that is my answer. That is my margin of error. That's how off I'm going to be. Then the next part says, find a 95% confidence interval estimate of the population proportion P. Now notice it doesn't say sentence, but every time you ask for a confidence interval, I'm going to make you write a sentence. And you're going to use the same sentence frame as you had highlighted before. Okay, so when we do this, and I'm going to show you guys by hand, I'm going to show you guys by calculator. Both ways are acceptable as long as you label the calculator, but again, we're going to do this by hand first. Okay, so by hand, our formula for confidence interval is right here. It's P hat plus or minus your E. So I'm going to write P hat plus or minus your E. What is your P hat? Well, you get your P hat as 0.43. So I'm going to do 0.43 plus or minus 0.025. And I know this is not 3 decimal places, but that's what they gave me. So I'm going to use my calculator, and I'm going to do 0.43 minus 0.025. So this is going to be the lower one because it's a minus. And again, 3 decimal places, which is what it gives me. So 0.405. And then a little cool trick is if you actually move up and highlight it, you can change this to a plus sign, or you could just add it up together, is you get 0.455. Okay. So this right here this is your confidence interval. Okay, this is your confidence level. So level is a percentage, your interval is a start and a stop. That's really what the difference is. And then we want you to write a sentence. And so we're going to write our sentence. So we are, and I'm just using the sentence frame if you look at it, 95% confident that the interval from, and then we're going to go from the lower to the upper. So the lower is 0.405, and then your upper is 0.555, contains the true value of the population proportion. Population proportion P. Okay. All right, so let's go on to C. And now C, I'm not going to do the second part because I'm never going to make you do this, but I'll explain it to you. We're just talking, we're going to answer, there's 2 questions, and we're going to go ahead and just answer the first one. So it says, based on these results, can we safely conclude that the fewer than 50% of the adults have Facebook pages? Now, we're not answering the second part, but let's go ahead and answer this part. Can we conclude that fewer than 50%? Now, my answers are 0.405 and 0.455, and that's really 40.5% and 45.5% if you converted these to percentages. So is that fewer than 50%? And the answer to this one is yes. And we're going to say since the confidence interval is less than 50%, because it's actually smaller than that, we can conclude that fewer than 50% of adults have Facebook pages. Now it says, again, the reason why this is because these two numbers are both smaller than 50%. Now, if this was like 40.5% and 50.5%, okay, 50% would be in between it, so then we can't conclude it because it's in between it. So we know for sure they're not lower, it could be higher. And that's, again, based off of what we know with the information. Okay, assuming that you're using your newspaper reporter, write a brief description or statement that accurately describes the results and includes all relevant information. Again, I'm not going to make you do this, but if I were to talk about this, what would you write? You would just write the information that you would use. I was like, oh, the sample size is 1,487. The sample population is 0.43%. If you did this study, you would find that 95%, which is our confidence level, 95% margin of error is 0.025, and the confidence level is, interval is 0.405 and 0.55, or 0.455. And that's pretty much it. Like, just like what information did you get, and then write it out in a sentence. Okay, that's what this is. All right, moving on to the next example. I just did a bunch of examples after this because I figured more examples the better. And again, I took most of these from your book. Some of these I came up with my own. But here's the next one. So it says, in a sample survey of 1,500 people, 34% said that they preferred playing games on their phones to help them go to sleep. Use 1.96. This is the z-value for 95% confidence interval or level. Okay, so it says, what is the margin of error of a study? Again, you can pause the video and try it out yourself, or you can keep going. So this right here is your n. This is your p hat. So p hat is 0.34. And what is q hat? I'm like the person that likes writing everything out before I start solving it because I know what everything means. So it's 1 minus 0.34, which is 0.66. Okay, so I'm going to go ahead and I'm going to solve this problem. So what's your margin of error? So that's your E equals Z of alpha over 2 star square root of P hat Q hat over N. And again, you don't have to write the formula every time. I'm just writing it because, you know, these are notes. So again, our Z is going to be 1.96 times a big square root, and your P hat is going to be 0.34, and your Q hat is 0.66, all over your N, which is 1,500. And again, we're going to round to 3 decimal places. So I'm going to kind of do this one a little quicker, but I'm going to do 1.96. 1.96 times the square root of parentheses 0.34 times parentheses 0.66, close my parentheses, divided by 1,500. And I'm going to get 0.024. Very close to the last one. And that is your margin of error. You're done. Okay. The next one says give a confidence interval that is likely to contain the percentage of people who play games on their phone before they go to sleep. Again, every time I ask for an interval, we're going to write a sentence as well. Okay, so your confidence interval is going to be your p hat plus or minus your e. So in this problem, our p hat was 0.43, and I'm going to add and subtract 0.024. I'm going to solve my problem, and I'm going to write my confidence interval right here. So I'm going to do 0.34. Oh yeah, this is 0.34, not, I'm sorry, this is 0.34. So I'm going to do 0.34 minus 0.024. I'm going to get 0.316, and I'm going to do the same problem, except I'm going to add. And again, it's always the lower and then the upper, so you can get 0.364. And then you're going to use your sentence. Again, same sentence frame. We are 95% confident that the interval, and from 0.316 to 0.364 contains, and I'm gonna stop there, but it's the same. It's gonna be contains the true value of the population proportion p. Again, it's the same sentence. I'm just gonna write sentence, but it's the same sentence as before. Okay, so we're gonna use the same thing, but we're gonna do this by calculator now. And again, I really want you guys to, you can use the calculator or you can do this by hand. It's the same formula, except I wanna teach you both. So it's in a survey of 1,300 people. So again, N is 1,300. 21% said that they preferred Twitter over Instagram. So I'm gonna say P hat is 0.21. So again, the first thing I would do is I would actually find Q hat. Actually, you don't even need Q hat if you're doing this by hand, you do. But if you don't, you're gonna need that. Find the margin of error in the confidence interval for 99%. So I changed this. And so I wrote the Z value here, but again, you're just using the chart or you're using inverse norm to find it. Okay, so the first thing we're gonna do this by calculator. It says find the margin of error. Now the sad thing is your calculator doesn't do that, so we actually have to find our margin of error by hand. So your margin of error formula is Z of alpha over 2 times the square root of P hat times Q hat over N. Again, calculator doesn't calculate that, you have to do it. So you're gonna do, it's gonna be 2.575, because this is now your new Z hat. You're gonna multiply that by 21 times 0.79 all over your N, which is 1,300. Again, you can't do this one by calculator, but you can find your confidence interval by calculator. Okay, so we're gonna go ahead and we're gonna do 2.575 times the square root of parentheses 0.21, close your parentheses, times 0.79, close your main parentheses, over 1,300. And I'm gonna get E equals 0.029. Okay, now let's go ahead and do this by calculator, because that's more interesting sometimes. If you don't want to do it by calculator, you don't have to. And you're using a calculator, yes, but we're gonna do something using the TI-84. Okay, so what you're gonna do is you're gonna go to stat. I'm gonna write it out first. So you're gonna go to stat, and then you're gonna scroll to test or tests. Okay, and then you're gonna go to letter 8, which is 1 prop Z int. And of course this pen is dying as well. So we're gonna go to this int, which is a 1 proportion Z interval. And that's exactly what we're doing. So we're gonna go ahead and go to stat. We're gonna scroll down to tests. And then you're gonna scroll all the way down to 1 prop Z int. Okay, and then it's gonna ask you some information. So your X value is the number of successes, if you remember back to the last chapter. So how do you find the number of successes? Well, if I know that, for example, I have 1,300 people and 21% said that they preferred Twitter, that's essentially going to be your N times your P value. Okay, so if you remember, I even wrote this formula out in the last chapter, so that's gonna be 1,300 times 0.21. Now, the beautiful thing about this is all you have to do is type that in, 1,300 times 0.21. And if you enter, it actually solves it for you, okay? My n is 1300 already, and then my confidence level is 0.95, which in this case is actually 0.99. Okay, and so again, what do you have to do? You actually have to tell me what test you're doing if you're doing this by calculator, and then you have to tell me what these values are. So 273, N is 1300, and C level is 0.99, and then you can hit calculate, and guess what? It gives you the interval. Now you can write all 4 out, that's fine. I don't mind you doing 4 decimal places, or if you want to write out 2, you can. But my confidence interval is 0.1809. I'm going to write round to 2 actually, so, or 3, 0.818 and 0.239. Okay, and then the last thing is you're going to go ahead and write sentence. Okay, so let's go ahead and go on to example 6, and then, yeah, we'll go from there. So it says, in a recent poll, a high school is performing a study on which privileges senior students should have. They want the margin of error to be 5.1%, which in decimal is 0.051. How many students will they need to survey? So this case, we're asking what is N? Okay, and then we're gonna say P is 0.14 and Z is 1.96. Okay, so first thing I like writing out the information, so I don't know what an N is. We know the margin of error formula. Let's go ahead and write the margin of error formula is Z of alpha over 2 times the square root of P hat times Q hat over N. Okay, so we actually know what our E is in this problem. We know our E is 0.051. Do not write 5.1. You have to convert this to a decimal because then you have to convert everything to percentages, which we don't want to do. So we're going to say this is 0.051 equals, I'm given my Z, 1.96, times a big square root. I know this is P, but P hat, I gave you the population, so this is 0.14. That means, how do I find my Q? Well, I subtract 1 minus 0.14, and I get 0.86. And I actually don't know what my N is. And you're going to be using a lot of algebra to solve this. Okay, so we're trying to solve for N. And how do we do that? Well, the first thing I want to do is I want to get rid of this 1.96. I can't square both sides just yet. So I'm going to divide both sides by 1.96. So this goes away. So if you think about it, you have this square root on this side and then this number on the other. So how do we get rid of a square root? Well, what's the inverse of a square root? Is you're going to square both sides. Okay, so the square root and the square go away. So on the left, and I'm going to write it over here, is going to be parentheses 051 over 1.96. And I don't want to type in anything into the calculator just yet. I want to actually solve as far as I can go, so I could just have to round once. But this is what you have, because you have this square root gone. So you essentially have this. And again, I'm going to keep it like this, and so I'm going to try to solve for N. And the first thing I'm going to do is I want to move N to the other side. So I'm going to multiply both sides by N. And why do I do that? Because this N and this N go away. And so I have N times this something. And how do I get N by itself over here? Is I divide both sides by 0.051 over 1.96 squared. Sorry, there's an extra parentheses. Over parentheses 0.051 over 1.96 parentheses squared. There we go. Okay, so this goes away, and look, I have N equals, and I have all of this information. So we're going to go ahead and use our calculator and solve this. Okay, so at the top I have, and this N has gone away, but at the top I have parentheses 0.14, parentheses 0.86. Divided by, and then I have this whole thing squared, and notice it's in parentheses, so it actually does matter. So I'm going to do parentheses 0.051 divided by 1.96, and then I'm going to square that, and notice it's in parentheses, and you have to practice using your calculator. There's really no way for me to teach you this. You kind of just have to know how to get your answers, but you get 177.8. I'm going to write that down. 177.8. Now, if you think about it, we're asking how many students, and you can't actually have a part of a student. So instead, we're going to round this to N equals 178. And we're always going to, even if this was a 0.1, we're always going to round up. You rather overestimate than underestimate. So you round up always. Okay, so that's your answer. Let's go on to the last page of this section, which is, again, a little bit more like quick little cool synopsis if you're trying to think about that. So it says, we already know how to find the confidence interval limits in the sample proportions or the best point estimate. p hat, and the margin of error, which is E. But let's go ahead and we're going to use some formulas, and then I'm going to use the formula. So how do you find your point estimate p hat if I give you a confidence interval? Okay, so essentially what this is I'm giving you the lower and the upper, and I'm like, hey, go ahead and tell me what these values are. Okay, so I'm going to draw you a little picture at the bottom. Okay, so you have a number line. And I gave you, actually, let's go ahead and write out the formulas, and then we'll do this example and I'll give you a picture. So the point estimate p hat is found by your upper confidence interval plus your lower confidence interval over 2. Okay, and your margin of error is found by your upper confidence interval minus your lower confidence interval all over 2. That's pretty much it. So let me give you a little example. So it says the article of a high-dose nicotine patch therapy by Dale Hurt includes a statement of 71 students, 70% were abstinent from smoking at 8 weeks. So a 95% confidence interval was 58% to 81%. Use that statement to find the point of estimate p hat and the margin of error E. Okay, so this right here is your confidence interval. It is 0.58 and 0.81. Okay, so I'm going to give you guys an image of what we're essentially doing. We're trying to say, hey, here's 0.58, that's your lower, and this is 0.81, this is your upper. I want you to tell me what your p hat is. What is the estimate number you're getting? What's the halfway point? And how do you find the halfway? Is you add the 2 and you divide by 2. And that's essentially how you find this out. So p hat is 0.58 plus 0.81 all over 2. And I already did this math. It's 0.695. Okay, so what that's saying is the halfway point is 0.695. And that is your point estimate. You're estimating that the middle is this. The second part asks you to find the margin of error. And what the margin of error is how far are you from like each end? Like they should be the same value because it's in the middle. You're trying to figure out how off are you. So if you're trying to figure out how off you are, what you're essentially doing is you're going to subtract these two numbers. Now pretend you didn't know this number. So essentially what you're going to do is you're going to subtract these two numbers and divide by 2 because that'll tell you what half the value is. And that's what our margin of error is. So it's going to be 0.81 minus 0.58 all over 2. Now for this one, it's okay if I flip addition sign, but it's not okay if I flip a subtraction sign because subtraction is not commutative. Okay, but if I do that, I get 0.115. And what that's saying is you're off by 0.115 each time. So if I take 0.58 and I add 0.115, I'll get this. And if I add 0.115 to that, I should get that. And that is the end of the first section of the video.